Welcome to the biological electron paramagnetic resonance lab at the Department of Physics, Boise State University. My research group is mainly focused on the development of electron paramagnetic resonance techniques and methods to study the structure, dynamics, and function of modal and biological membrane in the system that are relevant to human health and disease. My research group is interested in multidisciplinary approach in solving problems in biology and medicine by integrating physics, chemistry, and biology. Here, the active project that is going on currently on the group is the understanding the role of the membrane cholesterol in health and disease. Here, the health or the beneficial part of the membrane cholesterol is in islands. Here, the research questions that our group is asking is that what is the role of the membrane cholesterol in the lens that protects against cataract formation? So, cataract is a disease where there is a clouding of the lens, and with this clouding basically does the scattering of the light, and the that's the reason that you see the image is basically the blurred image. And by the age 80, like almost 50% of the people will develop cataract or will at least have a cataract surgery. So only the treatment, that is the current treatment for this disease, is surgery. Here in our group, we are trying to understand the fundamental interaction on the molecular level about the membrane cholesterol uh, that may lead to the development for the alternative strategy for the treatment of this disease. Here, another research project that my research group is interested on is atherosclerosis. That is basically the negative role of membrane cholesterol, or in the disease part is atherosclerosis. So, atherosclerosis is the disease in which the plaque is built up inside the arteries. Over the time, this plaque hardens and narrows the artery. This can cause like a serious problem like heart attack, stroke, or even death. Here our group is basically trying to understand the what is basically the role of membrane cholesterol in artery that may lead to the development of this disease. Here, the biophysical technique that we are using in our lab is the electron paramagnetic resonance. This is the EPR spectrometer that is located at the science building here at Boise State University. And you can see this is the magnet here that produces the magnetic field, and the microwave frequency through the waveguide passes through here in the resonator where the sample is kept. And here, this is the data acquisition system. Here, most of the EPR experiment we do is at physiological temperature, that is at 37 degrees centigrade. We also perform some EPR experiment at low temperature using liquid nitrogen, and here the experiment is done at 110 Kelvin. I am an assistant professor here at the Department of Physics, Boise State University. In addition to research, I am also teaching undergraduate physics lab this semester, and I'll be teaching biophysical instrumentation course on the fall of 2020. Raju and Naval are the two postdoctoral fellow working in my research lab, and Jackson, Mason, and Max are the undergraduate researcher working in my group. Our research lab is located on the Science Building 165D and the Multipurpose Building MP 311. There are a lot of graduate and undergraduate research opportunities in my lab. So, if you like to discuss about the research opportunities in my lab or join my research lab, please email me at Laxman Mainali at boisestate.edu. The research in the group is funded by the National Institute of Health R1 grant. Thank you. Have a great day.